screen. What is the first tool I have shown you?
Operational performance.
Operational definition. Operational definition is nothing but a two-line description about all the metrics that will be used in your project. Do you understand? Because you can't take things granted. Somebody might not even know what is a rejection rate, yes or no? They might know be part of your project team. They are there in the company for years together, but they may not have a proper understanding about what is rejection rate. So don't take things granted. Rather, write down a definition for all the important terminologies, important metrics that you will be measuring during the course of your project. Agreed, all of you? If you say turnaround time, we think like, everybody know the meaning of turnaround time. But when you ask them to measure, they'll go and measure something else. My data can accumulate error because of this poor understanding. When I say lead time, everybody know lead time. But what is the definition for lead time? When I say cycle time, what is the definition for cycle time? When I say throughput time, what is the definition for throughput time? Do you think all these time are same or different? All are same or different? Turnaround time, cycle time, lead time, throughput time, are they same or different?
Different.
So
Different.
you have to write the definition first. You should educate your people always on the start point and end point of measurement. Let's say you want to measure the speed of an electric motor. How many of you know the definition of speed of an electric motor? The electric motor is running and you have to measure the speed. How will see? We have to teach people. All of you agree or not? If you ask me to measure the speed of the electric motor, I don't know how to measure. You have to teach me, yes or no? When I come to your factory, you have to teach me, sir. You go to that, electric motor is there, an induction motor it is. You have to use the tachometer. Unless and until you tell me, do you think I will correctly pick up the tachometer and measure? I may use something, which I like. So you have to tell me, sir, this tachometer is the ideal one because it is a heavy duty motor. So use this tachometer. And I have a digital version also. Better use the digital version. Yes or no? And then don't take the reading, immediately. You must allow the motor to stabilize. Yes or no?
Yes.
You allow the motor to stabilize. When you say stabilize, I don't understand. Then you have to tell me, sir, let the motor run for 10 minutes. Now I understand. Oh, stabilize means 10 minutes. Okay. So machine has to run 10 minutes. After 10 minutes, I need to place my, what you call the tachometer exactly on the spindle. Some kind of, some mark is provided. And then I should wait for the readings to stabilize in my instrument. Yes or no, my reading also will keep on increasing. Can I take the reading immediately?
No.
No.
It has to reach the value and then remain stable. Now I will record it. And you will also expect me to do the same thing multiple times. Yes or no?
To take
Sir,
average.
don't just take one reading, take three readings. That is, if I take three readings, it is again confirming that the motor has stabilized. I also know how to take the reading. Yes or no? And my instrument also gives I mark the reading from the instrument after my instrument gives a stable reading. Do you understand, all of you? When I take three times, all three times when I get to know close readings, that means my data collection is accurate. Am I correct or not? That is why we take three readings, isn't it? If I take three readings back to back and all three readings are different, what does it mean? I don't know how to measure. Yes or no? I don't know how to measure. First time I'm, same thing only I'm measuring three times, but I'm giving different readings. As a system, I am not able to capture the fact correctly. You gave me the best instrument, well calibrated instrument, but still, what am I doing? I'm making, I'm actually collecting data with error. So if I'm struggling to repeat my readings, the error I am committing is known as repeatability error. How many of you understand? If I am struggling to repeat my reading, why should I repeat? Because it is the same thing you asked me to measure. If an appraiser or a data collector is struggling to repeat the readings, then he is actually committing an error known as repeatability error. All of you understand this?
Yes, sir.
Please confirm, because people easily get confused when we talk about measurement error. Very good. So repeatability error is understood. So now I took the reading, but the project leader is still doubtful whether Sivakumar measured correctly or not. He is very much doubtful about me. I gave all three readings correctly, but then also my project leader is not believing me. Then he sends one other person. Let's say he sends Mukesh Kumar. Now Mukesh Kumar also goes to the same induction motor. He also runs the machine for 10 minutes, and he also used the same instrument, and he takes three readings. He takes three readings, and his three readings are close to each other. That means Mukesh is giving a stable reading. Can you see that? The readings produced by Mukesh are consistent. Am I right?
Yes.
But my project leader still notices a problem. You know what is that problem? When I measured, the RPM was 2100 RPM. When I measured, my average is 2100. When Mukesh measured, his average is 2200. Do you understand?
Yes.
We both used the same instrument. We both went to the same induction motor. We both followed the same instruction. But I gave three readings close to each other. But so the average is 2100. Mukesh average is 2200. This is also an indication of measurement error. Yes or no? All of you agree with me?
Yes.
Now, two measurement system not agreeing to each other, right? The inconsistency in the reading while using multiple measurement system is known as reproducibility error. All of you understand? I must be
Okay.
consistent within myself. I must be consistent with Mukesh also. And Mukesh should be consistent with me. Yes or no?
Yes.
Then
Yes,
only
sir.
we all as a measurement system bring error-free reading, error-free data. If you don't respect all of these things, so the kind of instructions given to me as well as Mukesh are known as operational definition. The instructions that are given to the operator for data collection are known as operational definition. Clear, all of you? There are two types of error I told you. One is repeatability error. The other one is reproducibility error. Repeatability error means the error in the readings of a single appraiser while repeating the experiment. You can, in one word, you can say the inconsistency. In one word, you can say inconsistency in the readings of a single appraiser while repeating the same experiment is known as repeatability error. All of you understand the statement, definition?
Yes, sir.
Yes,
Repeatability
sir.
error is the inconsistency in the readings of a single appraiser while repeating the same experiment multiple times. Then what will be the definition for reproducibility error? The reproducibility error is the inconsistency, right, in the readings of the multiple measurement system. The readings produced by the multiple measurement system while measuring the same characteristics. What we are measuring is same only, but problem is readings are not matching each other. All of you understand? You should not unnecessarily confused here. One type of error is repeatability error. The other type of error is reproducibility error. When I add them, when I add them together, repeatability error plus reproducibility error, when I add them, the result is known as precision error. The result is known as precision error. So if I ask you a question, what is precision error? It is sum of repeatability error and reproducibility error.
Reproducibility.
Beautiful, beautiful. So this is what is precision error. There is a guideline for precision error. AIAG, the Automotive Industry Action Group, has created a guideline. The precision error should be less than 10% of the tolerance given by the customer. How much? Should be less than 10% of the
10%.
tolerance given by the customer. How do you know how much tolerance has given the customer has given? That is why I told you to write down all metrics, target value, upper spec, lower spec. You remember? For every metric you are dealing in your project, you must write the target value. You must write the upper spec, lower spec. The difference between upper spec and lower spec is what? Tolerance. Range, tolerance. Range of tolerance. Now, 10% of the range should be or otherwise the precision error should be less than or equal to 10% of the tolerance range. All of you understand? Precision error should be lesser than or equal to 10% of the tolerance. Let me give an example here. Let us say you are measuring length of a product. The diagram says, the design says, length should be 100 mm. Now, what is the target value? What is the target value?
100 mm.
100 mm. All of you, will you be able to write a definition for length? Length means what? Length means length of the product. That can be measured using some vernier caliper, right? Something. So, length of the product, target value is 100. Customer has given a tolerance of plus or minus 0.5. Now, what is the upper specification limit?
100.5.
100.5.
100.5. So, what is the lower specification limit?
99.5.
0.5 mm.
99.5. So, what is the range? Upper spec minus lower
99.5
spec?
to
1 mm.
1 mm.
1 mm. If it is millimeter, 1 millimeter. Now, precision error must be less than 10% of 1 mm. How much is 10% of 1 mm?
0.01 mm.
0.1 mm, not 0.1, 0.1 mm.
Oh, okay.
If at all any error is accumulating in your data, it should not be more than 0.1 mm. Then only measurement system is considered valid. Otherwise, measurement system requires improvement. All of you understand?
Yes.
Understood.
This is known as measurement system analysis. If this is done parallelly, you should also take care of your measuring instrument. Now I taught you how to take care of the measurement system. How to take care of the measurement system? When Mukesh, myself, Vijayan, and Vineet, all of us are involved in data collection, we all will undergo a training first. Yes or no? How to measure the speed of the induction motor. That is the training, no objective. It's a half a day training. And they will teach me how to use tachometer. Every part, every element of the tachometer will be taught to me. And then induction motor also, where exactly I should take, how to operate the induction motor, everything will be taught to me. This will certainly help in achieving consistency in our readings, yes or no? If we
Yes.
become more and more consistent, the precision error will become lesser and lesser. Correct? If all of us understand and do the correct way, then precision error will gradually come down. And the requirement is precision error should be lesser than 10% of the range of tolerance provided by the customer. Clear? And parallelly, one more thing we must check. We must also see to that the instrument is properly calibrated. What is the instrument we are using? Tachometer. The tachometer is calibrated once in 6 months. We have a calibration practice in our company. Every 6 months once, we are calibrating the tachometer. The calibration certificate should be available, and the tachometer should still remain in a state of giving error-free reading. Yes or no? If the tachometer also troubles us, then how can we achieve consistency? So tachometer or the measuring instrument should give error-free reading. If the instrument is troubling us, instrument is also giving some error, that is known as bias. The error that is coming because of the instrument is known as bias. All of you understand? Your instrument should not have any bias. Your instrument should not have any bias. If the instrument is having bias, it is demanding you to increase the calibration frequency. All of you understand?
Yes.
If the instrument is bringing bias every time when it is used, that means it is demanding you to increase the calibration frequency. Once in 6 months, procedure must be changed to once in 3 months. Do you understand?
Understood.
So instrument will not bring any trouble. Our team also, measurement system also will not bring any trouble. So our readings will be accurate. Whatever conclusion we make, that will be perfect. Now, all the instructions that are given to us, all the instruction given to the operators is known as what? Operational definition. The operational definition should not create ambiguity. Ambiguity means it should be free from confusion. Because if you give a definition in a way that people can easily confuse, you know what will happen? They all will make mistakes. Yes or no? So
Yes.
operational definition should be clear, concise. Concise means keep it small. It should be given in a language which the appraisers can understand. Visual illustration, right? And video illustration can be provided so that they correctly understand and then bring the data in an error-free manner. If in the absence of a, or in the presence of a poor operational definition, the consistency will get damaged. If the consistency damages, accuracy will also be lost. Consistency is known as the precision, isn't it? So precision error means problem with the consistency, right? And bias means problem with the accuracy. Do you understand, all of you? There are two things. One is consistency, the other one is accuracy. In order to achieve consistency, you should take care of your measuring instrument, also take care of your measurement system. After that, accuracy will be possible. If the measurement system is okay, accuracy is possible. But in spite of having everything in a proper condition, still your people are bringing data with error. That is known as the bias in our reading. Do you understand, all of you? So the definition of bias is difference between the measured value and the true value. Difference between the measured value and the true value. Let us say we have a true standard piece, length 100 mm. The standard piece length is how much? 100. I gave you a measuring instrument, maybe vernier caliper or something I gave you. And you are measuring the length of the part, let us say several times, 10 times you measured. You gave me 10 reading. All of it, you understand what is happening now? There is a standard part. What is the length of the standard part?
100.
100 mm. And I ask you to measure this standard part 10 times. I very well know it is 100 mm, but you are measuring like this 100.1, 100.2, 100.5, 99.9. Can you see some variation coming here? Can you see variation? Same part you are measuring 10 times, but you are going up and down. What is this error known as? What is our understanding? You have the repeatability issue. You have repeatability issue. Why are you doing like this? I am not revealing that you are measuring the same time, same thing repeatedly. Somehow I will manage to make you measure a part multiple times without letting you know that you are measuring the same part again and again. Right? So what happens? Some repeatability error. But anyway, the moment repeatability error appears, what will happen to the accuracy?
We get
Accuracy
down.
will go down. Yes or no?
Accuracy will
Yes.
decrease.
Accuracy will decrease. So let's see what happens in this case. So 10 readings are recorded. Now I need to calculate the average of the 10 readings. 99.1, 100.5, so many things. I calculate average. Now finally, my average is found to be 100.2. You understand? But what is the true value? 100. What is the average of the measured value? 100.2.
1.2.
Can you see a difference here?
0.2.
0.2. The 0.2 is known as bias, final bias. Why the bias appeared in our reading? Tell me all of you. Because of repeatability error. If I involved multiple people, maybe reproducibility error would also have appeared. My instrument might have some kind of what do you call the bias because my instrument is in poor condition. Anything could have caused the 0.2 mm. Am I right or not?
Yes.
If an error comes, you must think in the same line. Whether the instrument is properly calibrated. If calibrated, is it really in good condition? If instrument is not having any problem, then the problem is definitely because of repeatability or reproducibility. All of you agree with me? You have to check in 3 angles. One angle is instrument properly calibrated or not. Second angle, whether the person in appointed is he capable of repeating the readings. If multiple people are involved, the third angle also required. Are they measuring consistently? Are they following the same procedure? Are there any difference between the multiple people? All of you understand? Why this is so much important? Because we are dealing with the data. We are going to make decisions looking at the average. We are going to make decision by calculating the standard deviation. If they bring irrelevant data, all my statistics will become irrelevant. Yes or no?
Yes, sir.
And then finally my decision can get affected. This is how it is, and this is what you all must know before measuring something. And then you collect the data. After collecting data, you calculate DPMO, which I already taught you. Or you calculate yield. You know what is yield? Output divided by input. Very simple, right? Number of parts produced or number of parts accepted divided by number of parts produced. Imagine I produced 100 parts. 90 parts are accepted. Now, what is my yield?
10.
100 parts I produced, 90 are accepted. Now, what is my yield? Are you able to hear me?
Yeah.
Yeah. I produced 100 parts, 90 are accepted in the quality checking. Now, what is the yield of my process?
10.
90%.
90%.
90% is my yield. Rejection is 10%. If 95 parts are accepted out of 100, then my yield is 95%.
95.
So you know what is yield. This is known as traditional yield. The formula is number of parts accepted divided by number of parts produced. Now, there is one more yield known as first time yield or first pass yield. First time yield or first pass yield. Right now, the company believes that their yield is 95%, rejection is 5%. Now, I am going to the company and asking, sir, while getting the 95 parts accepted, are there any rework carried out? You understand my question? What is the question? Are there any rework carried out? Then they are telling, yes, sir. 25 parts are reworked. 25 parts are
Rework.
reworked. That means 70 parts are produced correctly in the first run itself. But 25 parts, first time they made a mistake, then they corrected. That's how they got the 95. And they are proudly declaring that their yield is how much?
95.
95%. Now tell me, if we conduct an examination, how many of you would like to pass the exam in the first attempt itself?
Everyone.
Everyone want to pass the exam first attempt. Nobody would like to fail and then rewrite the exam, arrears. But what are you doing in the workplace? Rework is similar to the arrears, yes or no? A failure has already happened. That is why people are reworking. So how can you give equal credit to the reworked pieces? Reworked pieces are not equivalent to the first time right pieces. Am I right?
Yes, sir.
So you must calculate one more yield known as first pass yield or first time yield. You understand? According to the definition now, first pass yield is equal to number of parts accepted without rework divided by total parts produced. Number of parts accepted without doing rework divided by total parts produced. Now tell me, out of 95 parts, how many parts are produced without rework?
70.
70. Total parts produced is 100. Now what is your revised yield?
70.
70.
But what are you discussing in the meeting? 95%. You are over projecting your performance. Can you see that? Actually, your yield is 70% only, but you are saying 95%. So you have a lot to improve. Can you understand? More problems are coming to the surface. This is the advantage of using the right tools. Clear, all of you? So please have a proper data collection plan. Check your measurement system is good as a whole, no complete system. Then you collect the data, then you measure your baseline. Baseline can be first pass yield, traditional yield, or DPMO. But in my opinion, first pass yield is good. All right. So this completes our discussion on what is this? The measure phase.
Measure
Maybe
phase.
I would like to show you the slides because otherwise you might think, oh, find it a little difficult. So I'll just quickly run through the slides and then we can go for the tea break and then proceed to the analyze phase. Data collection plan. Data collection plan talks about what is to be measured and who should collect the data, how he should collect the data and everything. And all see here CTQ measure. You have to write a definition and then you have to give the target value, upper spec and lower spec. Particularly when it comes to data type, there are two types of data. When in our example of induction motor, what we measured? We measured speed of the motor. Speed of the motor is a measurable data. Speed of the data is measurable means continuous. What is the unit of measurement for speed of the motor? Can somebody tell me what is the unit?
RPM.
RPM. Speed.
RPM. When a unit exists, the data is continuous. If a unit doesn't exist, the data is discrete. Please note. Another simple way of understanding is measurable data are continuous, countable data are discrete. And measurable will have unit of measurement, countable will be only numbers. Hope all of you understand what is continuous data, what is discrete data. And data can be broadly qualitative, quantitative. Quantitative means you have numbers. Qualitative means you don't have numbers. But when you have numbers, it can either be discrete or be continuous. Continuous means you have an unit of measurement. Discrete means you don't have unit of measurement. You only have count. You understand? Now let's do a small exercise. Tell me, turnaround time, is it continuous or discrete?
Continuous.
Continuous.
Customer satisfaction score, continuous or discrete?
Discrete.
Discrete.
Number of
Discrete.
transaction failed,
Discrete.
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 maturity amount,
Continuous.
balance, continuous. Rupees, we measure in terms of rupees. Time to resolve an issue,
Continuous.
Continuous.
yes. Number of cards that are linked to your savings account, discrete.
Discrete.
Second to process a loan application, continuous.
Continuous.
Client served, discrete.
Yes.
Speed of the induction motor, continuous. Temperature, continuous. Pressure, continuous. Velocity, continuous. Acceleration, continuous. Number of parts rejected, discrete. Number of suppliers, discrete. Number of employees, discrete. All of you understand? Operational definition, I told you, operational definition means clear, understandable description of what is to be observed and what is to be measured. See here, some example operational definitions are written. I expect all of you to write operational definition for all the metrics you will be using in your first project.
Okay.
This is another kind of assignment. One assignment is create a project charter. And in that project charter, if you say rejection rate, you have to define it. If you say, motor speed, you have to define it. If you say turnaround time, you have to define it. And the data collection plan, who should collect and how much data, what frequency, and all that, you must have a clear table. That is, the thing. And then measurement system analysis, you remember I explained you bias, repeatability, reproducibility, and gauge R&R. Gauge R&R, I did not talk. Gauge R&R, now I will tell you. I think all of you understand. I taught you what is precision error. Am I right?
Yes.
Sum of repeatability error and
Repeatability and
reproducibility error. I wanted you to compare this precision error with respect to customer provided tolerance. So you need to take a ratio, precision error divided by customer tolerance. When it becomes a ratio, that is known as gauge R&R. I'll show that. So I have also explained you this, why MSA must be performed. If you collect data without MSA, it is like driving a car by closing your eyes. But if you perform MSA and then collect the data, it is like you are keeping your eyes open, at the same time you are cleaning your windshield. Now the road will be clearly visible. You can have a safe driving. That is the idea. And this is definition for repeatability error. You have already understood. Now I want you to understand the statistical definition. You can read it. Similarly, reproducibility error. See here, multiple appraisers are coming. Earlier, there is only one appraiser, but multiple reading. But here, multiple appraiser, but they are differing from each other. And so there is a reproducibility error. The sum of repeatability error and reproducibility error is known as precision error. The precision error is compared against tolerance, and that gets a name known as gauge R&R. R&R stands for repeatability and reproducibility. The gauge R&R should be less than 10%. Then only the measurement system is considered good. Otherwise, in certain cases, 10 to 30% conditionally you can accept. But in any case, more than 30, you should not accept. And or when you want to calculate bias, you add all the reading, calculate average, and find out the difference between the average and the standard value. The difference is known as bias, right? And this is what we discussed about the measure phase. And then the yield, traditional yield, first pass yield, DPMO, CPCPK. CPCPK you will be learning next week. But this I have explained you. Traditional yield means acceptable output divided by total output. Acceptable units divided by produced units. But in first pass yield, we have to subtract what? The reworked unit, right? And DPMO calculation, you all know. So this is what do we mean by the measure phase. That's it. So we can go for a break now. Please come back by 11:25. Is it okay?